Hello all. This video is an extension to the previous video. If you haven't not watched the linear regression video, I would recommend you to go ahead and watch that and then start watching this one. So let's go back to our collab. So far we have predicted successfully, but the predictions that we had, the values that we which we predicted versus the original values, the distance is like very far. And now our goal is that we have to keep these red values on top of the green, which means that we have to reduce the loss. So to reduce the loss, let's calculate the loss. And so, so for the linear regression, we already imported this NN module over here. If in case if you don't remember, I already wrote from torch import NN. So let's now loss function is equal to okay is equal to NN dot L1 loss. Oh, this is nothing but the mean absolute error in the scikit-learn. It's the same one. So basically, we would like to understand the distance between here and here, and then we would like to reduce the loss. And also, I would like to have optimizers. So basically, optimizer very much important. Torch dot optim dot SGD. SGD stands for stochastic gradient descent. This is one of the optimizer methods, and also some few in few videos you can see that they do use atoms as well. But for now, let's focus on the SGD. So params is equal to, so we already have the model 0 dot parameters. Okay, learning rate is equal to, I'm going to give it a zero point 0.1. So what exactly is learning rate? Okay, so for example, learning rate in linear regression. So basically, step by step, it helps us to calculate the losses. So for example, here, let's look at the learning rate like zero point 0.1, tick, 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 something like this. This is called the learning rate, or else you can see here the low learning rate, the high learning rate. So right now we are going to use zero point 0.1 as a learning rate. So the other values that we can have for the learning rate is like zero point 0.1, 0.001 or 0.0001. So whenever we have like 0.001, the learning rate is like very slow, but the accuracy sometimes it may improve. So just we have to play with this one. This is called hyperparameter tuning in the machine learning world. So we have created this loss function, and also we have this optimizer, right? So there are no errors as of now. And now let's see what we can do over here. um, Neural networks regression. Okay, let's have a look at this one. So for example, over here, so this is the input layer and this is output. So basically we can consider this as input and this is the output. So we have input and we have output. These are the hidden layers. So we don't have to focus on these hidden layers at this moment, but for your understanding. So what I'm going to do is that we are going to do the loop. So we are going to train the model and we are going to predict the loss. And what we are going to, so once we start training the model from here to here, it goes from here to here, which is called forward pass. So we will calculate the loss. Okay, and once after we go over here, so we have calculated the predictions and we have the loss. And then what we will do, whatever the gradient descent that we do have, we will keep it as a zero. And in the deep learning, so basically what we will do is do the reverse one, so which is called backward propagation. And from the backward, so we will do what we will do, we'll start calculating the losses using those gradient descents, gradients, calculates the gradients, and then it improves the model overall model accuracy. And then, so once we start the model evaluation, which is a testing phase, we will turn off all the gradients, and then we will improve our accuracy. Let's see how it goes on. It's a lots of theoretical stuff. So now what we are going to do, torch dot manual seed 42, just to have like same output for you and for me. So I'm going to have a variable called epochs is equal to 1, right? For epoch, in range of epochs, I just want to loop this one. So let's train our model. Okay, model of 0 dot train. Okay, let's start the prediction. Train predictions. Train predictions is equal to model of 0 of so what we have earlier, we have x train, we have y train. Okay, and then we have x test, we have y test. So basically what I'm going to do, this is the data where I'm training the model, and initially I'm going to predict the y train values over here. So is equal to y train. No, this is to be x train. So let's predict the values. I mean, so basically what are the predictions we have done, we will compare this one versus this one. And now let's do the loss is equal to loss function of, I mean, when we are doing the forward pass. So let's calculate the loss function we already wrote over here, the loss function I'm calculating. So it's train rates, I mean whatever we have predicted versus whatever the original values. So print, let's print the losses here. Loss. Okay, loss. Okay, and now we have done here until here, we have came all the way over here, and I would like to turn off all the gradients. I'm not turning off, I would like to reset the gradient. So optimizer dot zero grad, right? And now let's calculate the loss in the backward. Okay, so now again calculate the losses in the backward and use those losses, and then let's optimize that one a step, and let's do the model 0 dot evaluation. Evaluation is nothing but the testing phase, right? It looks like there are so many steps, but it's all about like we started the training here, and we calculated the predictions, and we try to understand what is the actual values and what is the prediction value. And then once we reached at the end, so we resetted, we did the reset for the gradients, and then we calculated the loss in the backward, which is called backward propagation, and then we optimized this one more time, and then we started doing the evaluation. So let's print model 0 dot state dict. So this is one of the ways where you can see the values over here. Okay, so right now the value is 0.117, the tensor is this one. What's our original values? Wait, comma, bias, these are the original values, and it is like zero point 0.7 and 0.3. So now we have, so this is, I mean we have calculated so far, and what we will do, we will do the um, predictions. How we will do? With torch dot inference mode. So I'm turning off all the gradient descents over here, and here y preds is equal to, or test predictions is equal to model of 0 of x test, right? So we have calculated this one, and if you remember, we already have this function over here, plot predictions. Predictions is equal to none. If it is a none, so basically this one, so basically we do have the predictions, so it is the test spreads. This is interesting. Still, after looping that, we have our values over here. This is not at all going anywhere ahead. So what we will do, so we have looped it for once here. So let's loop it for 100 times. So again, I'm writing the code, loop over 100 times. So again, a machine learning model is all about like experimenting yourselves and experimenting with the data. So torch dot, again, let's write the code. I would strongly recommend you to practice the code along with me. So 42. So epochs is equal to, this can be any value. Epochs is equal to 100, and for epoch in range of epochs. Okay, so model 0 dot train. Let's do some training predictions is equal to model 0 of x train, and let's calculate the loss is equal to loss function of train rates y train, and let's see what's the loss here, right? And then let's do optimizer dot zero grad. I don't want any grads to be here right now. And now loss dot backward. Let's to calculate the loss in the backward. And then optimizer. Let's step it up. Step and model zero. Everything is completed. Evaluation is the testing phase. Let's print model zero dot state dict, which gives the weight and bias values. Okay, I mean this is like looking way too many values. So what I will do? Okay, so if epoch this value modulus of 10, I mean let's have this for every 10 values. Okay, once in every 10 values. Okay. um, okay, so okay, fine. So basically if we have here, you can see the tensor values, I mean the loss started reducing 0.066, and the values over here, I mean let's print a model 0 dot state dict. Let's see the best values. So it is like 0.7961 and zero point 0.3. So we have done it for like 100 times, and then so let's have a look at our graph. Plot predictions is equal to none. Sorry, predictions. Okay, let's do our predictions even before that. I'm so sorry for that. With torch dot inference mode, test spreads. This we are again calculating after like looping it for 200 times. Test spreads is equal to model 0. This is our model of x test. So I'm giving this the same value over here. See over here. After like 200 epochs, is I mean earlier it was here and now the data has gone here, but still there is this distance from the original values versus the prediction values. So which is not ideally this is good, but let's see what else we can do. Let's see how further we can loss um, the so far what we covered earlier, so our graph looks like this, and then we have looped the same the code for 100 times, and our values are over here. In the next video, I'm going to talk about the training and the testing loops, where basically where we write the code here, and also we do the inference mode within the testing loop, so which helps us to improve the accuracy. So thank you for watching these videos. Please keep on watching my videos and please do subscribe. Thanks.